Hello, let's do the New York Times Hard Sudoku for January 14th, 2024. There's a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. All right, let's start at the top band here. We do have two 5s looking into this box, so there's a 5 in one of these two. Briefly scanning for 1 8 in this row, but definitely not interesting. Also 3 6 in this row, but really this row is pretty empty, so I'm probably not going to find much there. In fact, all of these rows are pretty empty. I'm going to look for crossings real quick. Like on this 1 5, we looked at the 7. On this 3 6, I'm looking for anything here and here, but this is just all very empty. Let's move on to the next band. We do have 2 7s and a third 7, and then this one's not 7. So 7 in this box is limited to this one cell, so we can place it because it's what's called a hidden single. All right, that does make 2 7s look up. So 7's in one of these 3 cells. We're not sure which one. We use quarter marks for that, or where a digit can go in a box. Okay, we have a bunch of 1s looking into this. Yep. That does allow us to place this 1 in the box. It's hidden single again. We have 2 1s looking into this box, and this one looks up, so it's in one of these 2 cells. 8s are looking into this box, so there's an 8 in one of these 2. I'm thinking about the 1 and the 6 in reference to this row. Can't go there. Can't go there. Ooh, that's very close. So what I'm seeing is the 1 and 6 are limited to 3 cells in the row. If any of these cells get filled with a non-1 6, we should try to remember to go and look at that 1 6 again. I don't know if I will or not, but we'll try. Looking for... Okay, the 4, 1, 7 are already in this box, so that's not helpful. What about in this column? So we already have a 1, but we do need a 4, 7 in this column. There we go. Finally found one. So this column needs 4 and 7. And they can't go here, and they aren't down here, and this isn't it. So there's only 2 cells in the column that can have 4, 7, and the column needs both 4 and 7 still. So this is what's called a hidden pair. And I do know that this 4 looked in, but I wanted to explain the hidden pair first. So, because that's how I saw it, you could have seen a hidden single 4 and then a hidden single 7. But anyway, this is how I saw it, because I looked at this 4, 7, and I said, hey, where do those go in this column that they're not in? Because they can't repeat in the box. And so we need 2 cells for the 4 and 7. There are only 2 cells for the 4 and 7. So those 2 cells can only be 4 and 7. And so now because this 4 looks in, we actually know what order they go into. This is the 7, this is the 4. So hopefully that made sense. I explain it a lot, so if I didn't make sense this time, maybe next time. All right. There are 4. Yeah, so we need the 2. The 2 looks up. The 2's in one of these 2. So this 2 looks up, and these 2's point down, preventing this from being a 2. Basically, if you want to think about it in one way, if this were a 2 right here, where would we put 2 in this box? And the answer is we could not put it anywhere. So these 2's, because they line up in the column and aren't anywhere else in the box, they point down and say, hey, the rest of the column can't be 2, or you're going to break my box. So don't do that. So 2's in one of these 3. In fact, we don't even need to do that. We can just fill this triple. It's 2, 3, and 9. There are no 2, 3, 9s looking at it, so it's just a 2, 3, 9. But this is also a triple, and we know the 8's not here. So the 8's over here. What else do we need? We need a 5 and 6. Okay, also nothing looking at that, but we do get we have the 8's. We have a 5, 6 here. That could be helpful. We do have these 2 4's looking into here, and this 4 looks up, so 4 is one of these 2. Did I say there was something about 1 4's I wanted to check, or was it the 1 6? It was the 1 6. This can still be 6. Okay. Anything else to find here? Not that I see. What about up here? Let's think about these 4, and I'm going to think about this as well. Yeah, like we need the 7. So the 7's in one of these 2. Unfortunately, nothing else is needed in that column. The 4 is needed, though, and then this 4 looks in. So 4 is in one of those 2. 1's not helpful. Okay, and what are these 4 digits? The 2, 3, 6, and 9. I mean, I see this 6 and this 3, but it's not really worth marking at the moment. Let's find more information first. Okay, I'm going to move on to the next band here. So I'm looking at this 4, 7, 9. It just sort of sticks out once you know what to look for. And then I'm just scanning this for 4, 7, 9. And I'm noticing that 4, this 4 sees here, this 4 sees here, and this 4 sees here. 4 is a hidden single in this row, because 4 can't be in any of these cells, and 8 and 2 aren't 4. So the 4 has to go there in that row. And so now these two 4s look in, and this 4 looks down, placing this 4. And how are we doing on 4s, really? We got 4s, yeah, so I already have it marked in this box. We have 4s in one of these two, and then 4 in one of these two. So we can corner mark that. So we just have this one rectangle left of 4s. What about 7 and 9 in these 3 cells? I'm not seeing anything special about that, so. All right, we do have 2 2s looking in, so that does actually place a 2 here. I'm looking vertically to see any consequences. Always good to do when you place a digit. Nothing, there were no consequences that I could see, but still. We need a 3, 5, 8, 9 here. So I'm seeing the 9's not here. So the 9 is in one of these two. This isn't 9 or 5. So I said 3, 5, 8, 9. So this is 3 or 8 only. This is 3, 5, 8. These are... This one's not 3. Okay, yeah. I don't know if I want to mark the rest right now. Well, this can't be 8. This is 3, 5, 9, though. You know what? They're all triples, so I am going to fill it just for posterity. We need 3, 5, 8, 9, and they're all triples in a different way. Okay. And then this row has 4 left as well. So we need a 5, 6, 7, 8. This can't be 7 or 8 or 6. So this is a naked 5. Very nice. So let's just double check. It can't be 1, 2, 3, 4. We said it could be, we said it's a naked single 5, so it can be 5. It can't be 6, 7, 8, or 9. There we go. So it's a naked single 5, so that's not 5. So now we're down to 3, 7, 9 here, and you can see that the 3 and the 9 make this the 7. So there's a 3, 9 pair here. The 5 we got looks up, giving us this 6. And guess what? I did remember we were looking at 1, 6 in this row, and now this can't be 1 or 6. So 1 or 6 can't go here. They don't go in any of these cells, and this 1, 6 tells us they don't go here. So these are the only 2 cells left that can be 1, 6. So we found a hidden 1, 6 pair here. I'm going to think about the rest of this row. Ooh, there's a lot in the rest of this row. I'm not going to think about it. Sorry. For some reason, I thought it would be a quad like this, but no, definitely not. All right, there's a pair here, though, that's for sure. Let's look at this. We need a 6 and a 7. And actually, that's really nice, because that 7 tells us the order. So the 7 goes... Oh, no, we don't need a 6 and a 7, so that's not as nice. I misscanned. We need a 6 and an 8. Yeah, that's not as nice. They don't resolve. But we do have 6s lining up here, but there's already a 6 in this column, so that's not actually helpful. All right, the 6, 8 pair does eliminate 8 from here. The remaining triple is going to be 5, 7, 9. Okay, 9's up here somewhere. Ah, if 9's up here somewhere, then it is not here, right? Oh, no. Sorry, I made that mistake in an earlier puzzle. It's the 7s that are up here. Luckily, I caught myself, because that felt wrong last time I did it, and it felt wrong this time, so I'm glad I double-checked it this time, because I was like, wait, how does that work? It didn't. It didn't work. That's how that worked. Anyway, 7's pointing is not as interesting, because we already have 7s everywhere. And that makes a lot more sense for it to be pointing 7s and not pointing 9s. Okay. I need to be careful about that. I'm just going a little fast and misscanning things. All right. I'm going to look vertically. I'm going to start here because we have 3s in one of these two, which I noticed. We also have 2 4s. Okay, we have all the 4s. 3s we did, 6s. 6s we have basically cornered here. Yeah, that's it. The 7 doesn't... Does the 7 do anything? No. All right, and vertically here, I feel like I covered, but did I think about that? Yeah, I thought about this and decided not to mark it, but at this point I will. So we need 2, 3, 6, 9. Right, this is 2, 3, 9. And these can't be 2, so these are 3, 6, 9. That's not a 3. Yeah, so we're left with this 3, 6, 9 here and this 2, 3, 9 here. So the 6 is up here. Okay, what about over here? Did I look vertically here? Not officially, but I feel like there's nothing to find. Unless there's a crossing that I haven't really been scanning for crossings in a bit. So maybe there's something of interest there. Not really seeing it. All right, let's think about all of these digits that we've gotten recently. We got the 4s, the 7s. Yeah, the 7s aren't helpful. The 6 here. We got the 1-6 pair. So maybe this 1-6 pair helps the rest of the box in some way. Well, no, because the box already knows it can't be 1-6 here, here, and here. So that's another way we could have found that hidden 1-6 is via the box. I'm trying to find anything that doesn't involve let's just pencil random cells, but that may be the next step. Just doing another quick scan just to make sure, but like 1, 2, 3 maybe. The 3s I have marked. Yeah, that doesn't help me. I do need a 1 in this row. Yeah, so 1's one of these two. What's going on with 1s in this box? It's like this. And then, okay, so this one looks in, this one looks in. So 1's in one of these two in this box. Okay, I do think I'm probably just missing like some restricted cells. So I'm going to start thinking about where those might be. Maybe something like this cell. Let's think about all 3 of these. So we're not going to talk about 8 because 8's already in the row. We'll talk about all the other digits that the box needs. So we need 1, 3, 5, 6. So this can't be 1, this can't be 5, this can't be 6. Wonderful. Well, 6 actually isn't down here either. Yeah. So 6 is in one of these two. 5, though, is in these cells, so that's not as interesting. This is still not amazingly interesting, but it's something. How about this column? What does this column need? It's going to be 5 digits. We need 2, 5, 7, 8, 9. I'm noticing 8 isn't penciled anywhere, but there's 3 places for it. I said 2 as well. No. It was 2, 5, 7, 8, 9. This can't be 5 or 7, so this is 2, 8, 9. Kind of grasping here. Neither of these can be 7. So actually, 7's in 2 places. That's something we might want to remember. We can't place it. If this 7 was here, this would be 5 and 1. Interesting. And that cascades to here. It cascades to here. That would be quite nice, but we can't just try it. Well, we could just try it, but that's not what I'm going to do. What else is going on here? There's not like a good restricted row column or box to latch onto here that I haven't already penciled. So I'm thinking about whether there's a restricted cell that sees a lot in its row, a lot of distinct digits in its row column or box. Those are ones that I still have trouble scanning for. Sometimes I see them, like this one here. Actually, this whole column might be good to think about, but this cell here specifically sees 1, 2, 3, 4, 5, 6, 7. So I think it can be only 8, 9. But I'm going to think about this whole column. So the whole column needs 1, 5, 6, 8, 9. Yeah, that's not... Okay, this can't be 1 or 6. So I said 1, 5, 6, 8, 9. Okay. Oh, the 1. Okay, the 1 is in 2 places. Darn. I'm seeing this like 5, 6, 8, 9 here. But there's really nothing to do with it. All right. Look elsewhere. This sees 2, 6, 7, 2, 4, 8, 9. So this is down to 3 digits. This can be 1, it can't be 2, could be 3, can't be 4, could be 5, can't be 6, 7, 8, or 9. I feel like it's this 1, 6. Let me focus on this 1, 6 a little better, because this was a hidden pair. So what was removed from here? A lot of digits. So they can't be 2 anymore. I'm looking to see the consequence of these not being 2. I don't see anything. Okay. They can't be 3 anymore. Well, the 3 was already marked here. But I think the 3 got marked here because of the 1, 6. Anything else with 3s? No, the 3's got marked here because it's these C3s. No, but this one didn't C3. Okay, so this not being 3, I don't think it does anything. They can't be 5 anymore. Both of them wanted to be 5, potentially. So what are we thinking about with 5s then? Not much. 5's here. Ah, actually, yes, that's it. That's it. Where's 5 in this column now? Look at that. This 5C's here, this 5C's here. This 1, 6 hidden pair that we found eliminated 5 from here, and this 5C's here. Very nice. Okay, so if I'd found those 5s marked, and actually I knew that would happen because I saw that 5s were lining up in box 3 and 9. It's a really good technique. This is not technically an X-Wing. You could think about it as an X-Wing if you want, but we don't call it an X-Wing because it doesn't span 4 boxes, because it's always going to, it's always degenerate because it can be described through the simpler method of looking at the column they're not in, because they're only in 2 boxes. But anyway, this is, if you want to think about this like an X-Wing, then it eliminates 5 from all of these cells, which has the same effect of us realizing that 5 in this column, that these can't be 5, and thus 5 in this box is here. So that's one way to see it. But probably, in my opinion, the simpler way to see this is the 5 in box 3 and the 5 in box 9 are avoiding column 8. And because they avoid column 8, the question we want to ask is, where does 5 go in column 8? Well, it's not in these boxes, because that's how we found that, and it's not in these 2 cells. So anyway, we can place this 5. That gives us 8 and 5. So 5 looks down here, and these 5s look in. So 5 is placed here. Now 5 in this box is super interesting because it's only one place. That gives us the 5. Oops. Gives us the 5, the 1, and the 6, leaving a 3-8 pair. That's 9 and 5 then. That's a 3. These are not 5. Whoa. Ooh, wow. Okay, that's not what I wanted to do. These aren't 9s. That's not a 3. This is a 2-3 pair and a 6-9 pair that's left. Okay. This isn't 5 anymore, so 5 in this box goes here. 5s are done. Very nice. So that's what we were missing. So let's think about this box then. In fact, let's think about this column. This column needs 2, 7, 8, 9. Neither of them can be 7. So in fact, 7 in this column can only go here. That's 7 and 9. So these are 2, 8, 9, which doesn't appear at all resolved. But I'll fill it. And then these are 2, 3, 8. And the top one can't be 8. Okay. In fact, this whole row is 2, 3, 9. This can't be 2, so it's 3, 9. This is not a 4. Interesting. So what do we actually need in this row? It's 5 digits. It's 2, 3, 4, 8, 9. So this is 2, 3, 8, 9. Okay, that's not interesting. This is also 2, 3, 8, 9. All right. What else am I missing here? I just got a bunch of 5s. This 2, 3 pair and 6, 9 pair feel important, but oh, interesting. Okay, how about this column? This column needs 1, 6, 8, 9. It can't be 6, so 1, 8, 9. Wow, I thought that this 5 that I got would would collapse everything, but it didn't. So there's one more thing to find probably. We need 1, 2, 7, 8, 9 here. Yeah, so 7's up here. 1, 2, 7, 8, 9. Yeah, that's not that interesting. Beyond what's corner marked. The 9 is up here. There we go. So this column, maybe not there we go, but let's see. This column has 9 only up here. So that does what's called claiming. So if 9 is up here in this column, then the rest of the box can't have a 9, or this column won't get one. That's called claiming. The column claims the 9 from the box. So that's not a 9. It's a very similar technique to pointing. And in fact, we could have said these 9s point and eliminate 9 from there. It does the same thing in this case. Doesn't have to, but in this case it does. So if that's a 2, 8 only, does that help somehow? I don't know. Does this see a bunch of digits that we need? 2, 5, 6, 7. The 5 and 7 we don't care about, but the 2 and 6. are not in here. So what is in here? 1, not, yeah, 1 is fine. Okay. Not 2, could be 3, not 4, 5, 6, 7, could be 8, 9. Darn. That's not even that interesting. It's 4 digits left. This one can't be 1, could be 2, could be 3, can't be 4, 5, 6, 7, could be 8. There we go. That's a 2, 3, 8 triple. So I was 1 off on which cell to look at. But that's a 2, 3, 8 triple. So the rest of the row can't have 2, 3, or 8 in it. So this isn't 3, 8. This isn't 3, and this isn't 8. So that gives us this naked 2. That's 2 and 3. Wait. No. That's part of the 2, 8, 2, 3, 8 triple. We can't eliminate 3 from it. Sorry. This can't be 8, though. Okay. So that's a 1, 9 pair. So 6 in this row is only here. That's a 9. I don't think I need this triple anymore marked, but couple times on this puzzle, I've almost made a horrific mistake that may or may not have led to a contradiction, which is the problem. Because if it doesn't, then I don't know I've made a mistake and can't correct it. Okay. Until the comments tell me. What is this not enough? The 1, 9? Actually, 9 in this column. No, 9 is there. We already found that. Eliminating 8 from here doesn't seem to have helped. How about here? 8 is in these two. Let's think about this column. So we need 1. I'm just going to write it out. We need 1, 3, 4, 8, 9. Wow, look at that. 3, 4, 8, 9. Okay. This is a naked single 1. It can't be 2, 3, 4, 5, 6, 7, 8, or 9. So it's a naked single 1, and that's very helpful because it gets us the 9 and the 1 here. Gets us the 6 and the 1 here, the 8 and the 6 there. It gets us the 9. That's a 3, that's a 2, that's a 9. Let's clean up the 1, 3, 9 from here. Clean up the 9s from here. Clean up the 2s from here. This is the 3 in the box. That's 2 and 3. We get the, let's see, 2, 7, 8. Okay. Oh, this can't be 2. The 2 looks in. Oh, okay. So that's the 2. That's the 3. So yeah, I would have gotten very lucky. That's 8. That's 2. That's 7. That's 8. That's 4. That's 7. That's an 8 and a 4. That's 3 and 8. That's 9 and 8. Over here, we do need a 2 and a 9. And then up here, we need 2, 3, and 6. So that's the 3. That's the 2. That's the 6. Wow, that took me a while. 2239. Wow. Okay, so that's one of the longer solves. Yeah, I got hung up on finding 2 things as far as I can tell. It was, let's see, what were the 2 important things? It was the it was something in this column. It was the 5 in this column, the 5 being hidden in this column. Got hung up on that. And then it was this random 2, 3, 8 triple here, which how did that one help? I think, did that make this a naked 1? Maybe this was just a naked 1 the whole time and I didn't need to find the 2, 3, 8 triple. It's hard to know without going back, and I'm not going to do that right now. But yeah, hope you enjoyed this solve, a bit of a longer one. And of course, if you did, then why not leave a like, subscribe, and a kind comment below.